All right, I'm going to show you a problem of a hydrate, how to calculate it, how to think about it, what to go through. This one is definitely wordier than the majority that I assigned to you, but I wanted to put a couple extra things in here for you to look out for that might happen, not in every problem, but here and there you might run into them. So you can take a look at them and know how to deal with it, because this problem has pretty much anything you can look at. So the way it reads is we have a hydrate of strontium oxalate, right? It doesn't give it to you. Most of the time I will, but we definitely want to know what that is. Was weighed, then heated until it was in anhydrous salt. Okay, that's all good. That's how all these work. As you read the lab, you're going to notice that too. But we definitely want to know what that anhydrous salt is. The original mass of the hydrate, all right, so hydrate was 118.3 grams, and after the heating, I guess in this point was after it was 90.7 grams. So it says find the hydrate's formula. All right, so all of these are basically set up the same. I'm going to write what we know. All right, so the first thing in this problem, what you'd have to do is you'd have to come up with what the heck is strontium oxalate. All right, so strontium oxalate is SrC2O4. All right, now oxalate again is not one of those I'm going to make you do. Remember, if you got carbonates, sulfates, nitrates, that type of stuff down, those, if I gave you a word, I would expect it, but this one I'd probably give it to you in a normal problem. Either way, we're good to go. Knowing what we know that this is a hydrate, and so what we're trying to find is this N. All right. Some, if you're looking at some things online, they might call it X or something else, but we're trying to find this NH2O. Okay. So the way that this one works out is it kind of looks like we have a decomposition reaction. And so we end up with the SrC2O4 plus NH2. And you're thinking, okay, side to side, that doesn't look a lot different. But what it does is it gives us the hydrate here, and it gives us the anhydrate here, plus the amount of water that we're looking at. So if we go back in and we fill in what we know is the hydrate was 100. So that's this whole thing, right? This whole thing was 118.3 grams, right? And after was 90.7. So we got to think of, what does that after mean? That after, what is left, what we have left in this case, the way it's worded, is this anhydrous salt. So this guy weighed 90.7 grams. Okay, and that's all they give us. Some problems will give us more, others won't. So the idea is we got to figure out how many grams of water is left. Well, what we do know is the law of conservation mass says what goes in has to come out. So if we do this, right, we should end up with this guy being, the H2O should have a mass of 27.6 grams. Okay, so that's kind of more than we typically have to do. Sometimes I give you all of those in the problem and you just have to decide which one you need, and vice versa. So what we need to do is, just like our empirical formula problems, we need to figure out how many moles of that and how many moles of that we have, so we can compare them, so we can find this unknown N. All right, so the way we're going to do that is we're going to start with what we know. We know that we have 90.7 grams of SrC2O4, okay, and we have 27.6 grams of H2O. Right? We're not really caring about the N yet. We're going to figure that out in this problem as we go. So that's what we know. All right? So the next step is we have to convert to moles. Just like last week, this week is all about determining the number of moles of something so we can compare. So we're going to put grams of H2O on the bottom here. We're going to put grams of SrC2O4 on the bottom there to get rid of them. Just like last week, the only thing we can use is moles for a ratio. There's got to be moles in every ratio at least one spot. So we're going to put moles of SrC2O4 on top and moles of H2O on the bottom. Okay, these numbers come from the periodic table. So for H2O, using 3 sig figs, it should be 18.0 grams. And adding up all those parts and pieces for the strontium oxalate, we should have 175.6 grams. All right, and that's always per 1 mole. All right, so what does that get us? That